Hello, good afternoon, everyone. Let's get started. So last class we were talking about discovery science, where it involves making observations, and with observations we can do qualitative observation, which involves using our senses, or we can do quantitative observations, where we'll be using measurements. And we talk about how once you make all these observations, you can try to use inductive reasoning to come up with a generalization. And in some cases, you can use that generalization in a new example, in a new situation, and apply it to those specific cases. And that would be called deductive reasoning. So today, we will spend our time talking about the second way of how science is done. In addition to discovery science, we can also do what's called hypothesis-driven science. Okay, so we talked about the process of a scientific method last time, briefly anyways, and that involves all these steps. And we use the example of a remote control not working to kind of see how this relates to something that we are familiar with. So today we're gonna explore more on this topic, and we'll try to use other scenarios to help you really see how the scientific method works. Yeah, so we'll be taking quite a bit of notes. Please make sure you have some paper and pencil with you as we move forward. So let's use a new scenario now. Instead of the remote not working, we're gonna look at plants. Let's say you have two house plants, and you notice one is growing taller than the other. Right? So the first step in the scientific method is making an observation. Right? So we observe that one plant grows taller than the other. Then the observation is going to lead to some questions. The logical question to ask here is, why is one plant taller than the other? Okay, so that's our question. So after making the observation, asking a question, the next step in the scientific process is to come up with a hypothesis. And so a hypothesis is like a tentative answer to your question. It's some people call it like the educated guess, right? What's your best guess as to why one plant is taller than the other? Anybody want to help me out here? Why do you think this is the case?
Probably not watering it enough.
Yeah, that could be a possible reason. So your hypothesis would be one plant is receiving more water than the other. That's why it's growing taller, right? Does anybody else have something different?
Getting more sunlight.
Yeah, that's also possible, right? One plant is receiving more sunlight than the other. So we try to answer our own question by proposing a possible answer. And that's what a hypothesis is. Now, when we write hypothesis, we need to make sure that it is a valid hypothesis. For it to be valid, two conditions needs to be satisfied. Okay, number one, we need the hypothesis to be testable, and we need it to be falsifiable. Testable means we can do an experiment to validate or reject the hypothesis. Okay, there has to be a way for me to test it to see whether it's true or not. And secondly, it has to be falsifiable. Falsifiable means it has to be potentially wrong. After all, you're not going to create a hypothesis that is always correct. I mean, what's the point? If it's always correct and you kind of know the answer to your question already, there is no point of testing it, right? So the whole point of doing a scientific investigation is to find answers to things that we don't know. So when we come up with a proposed answer, when we do the hypothesis, it must be testable and it must be falsifiable. Things that cannot be included in a hypothesis are things like opinions, cultural or religious belief, superstitious things, myth, values, moral judgments, supernatural things. These things are not testable, and therefore you cannot include them in a hypothesis. All right. Now, I just want to remind you, because a lot of people write the wrong hypothesis in the lab. I told you have to do a lab for me later, right? The beetroot experiment. And in that lab, I will ask you to give me a hypothesis. And people do it wrong because they forget a hypothesis is a tentative answer. Here, let me write that down for you. Tentative answer to your question. So you should not write a hypothesis as a question. Okay, it should be a statement. Okay? It should be a statement. I guess we'll get into more detail when we get closer to the lab. But I just want to throw it out there at this point to remind you: hypothesis is a statement. Okay, that answers your question. So let's take a look at some invalid hypotheses. Plural of hypothesis is hypotheses. Okay. So animal testing is bad. Rock music are better than classical music. Why are these invalid hypotheses? What's wrong with them?
Personal opinion.
Yeah, they are personal opinion, and therefore, yeah, it's subjective, and they are not testable, right? So these are not testable. They cannot be tested. Opinions, personal preference. Okay, next one. The garden fairies made some plants taller than others. Or everything that occurs is as a result of divine intervention. What's wrong with these ones?
Personal beliefs.
Yeah, they could be personal beliefs, but more importantly, they are not falsifiable. Not falsifiable. Falsifiable. For example, one person can spend a lot of time in the garden looking for garden fairies, and they didn't find anything, right? So they say garden fairies do not exist. But the counter argument for that is, well, just because you haven't seen one does not mean they don't exist, right? Maybe you haven't waited long enough. Right? In fact, you can spend your whole life looking for it, and if you still don't see one, the counter argument will always be, well, you're just unlucky. You just have to wait longer, okay? Or someone else have to wait longer. So in that kind of regard, this statement is not falsifiable. Okay, it can never be shown to be wrong, and therefore it's not a valid hypothesis. Does that make any sense? Thank you, Eduardo. And hopefully the rest of you also understand this. Okay, let's take a look at some valid hypotheses. Okay, plants receiving more sunlight grows taller. Right, we actually talked about that a couple of slides ago. That's a valid hypothesis. I can easily test this. We can put plants with sunlight, with no sunlight, compare it after, and see, right? I could be wrong. Maybe it's not the sunlight, maybe it's the soil, maybe it's the temperature, whatnot, right? So it's testable and it's falsifiable. Another one, driving with the windows down will increase fuel consumption. So that's, again, something that you can test. This thing is like heavily debated on the internet. I think some people say, driving with the windows down is going to save fuels because you're not wasting energy turning on your heat or AC in summer or in the winter. Some say if you drive with the windows down, it increases the resistance and therefore uses more fuel, right? Well, we don't know. I don't know. But it's something that we can test if we wanted to, okay? Do you guys know melatonin? Anybody know melatonin? Anybody take melatonin? Do you know what it is?
Doesn't it like help you sleep?
Yeah, so melatonin is a natural hormone that your brain makes to help you sleep, but you can also take it as pills. And believe it or not, there are actually not enough studies to show definitively that melatonin, when you take it as a pill form, is going to help you sleep longer or better. Right? Some people think it's a placebo effect. Okay, if you don't know what a placebo is, we're going to talk more about it. But in a nutshell, it's kind of like a psychological effect. Right? You take something, you believe it's going to help, and therefore, you end up sleeping better. Right? So again, that's something that we can test, and it can turn out to be potentially wrong. All right, so these are valid hypotheses. So then once we have the hypothesis, we can make some predictions, and we're going to go ahead and design an experiment to test the hypothesis. Okay, so in an experiment, there are things that are going to change, and we try to keep as many things the same as possible. And anything that we do end up changing, that's what we call a variable. Okay. So in doing an experiment, we try to keep all the conditions the same. And then another way to say that is that we try to standardize everything except for two variables. One of them is called the dependent variable. The other is called the independent variable. Now, if this is your first time learning about this thing, it's going to be a little bit confusing. I'll try my best to explain. And the most important thing is to ask me questions if you don't understand. Okay, so let's talk about the independent variable first. Independent variable, and you need to know this for the lab. Okay, you will have to explain what it is, and you will have to know, in that experiment, which one is the independent variable, for example. So independent variable, this is the variable that is changed by the person doing the experiment. Okay, one way to remember this is that the independent variable is the one that you are in control of. Okay, like you, as in the person who's doing the experiment, you get to deliberately change the independent variable. Okay. Now, you should only change one thing at a time. Right? Like if I change the amount of sunlight and I change the amount of water, and one plant ends up taller than the other, then I actually don't know if it's the sunlight or if it's the water, right? So for the experiment result to be meaningful, you should only change one thing at a time. And the thing that you are changing, that's the independent variable. Okay, so let's use our scenario, right? Our hypothesis. I'm talking about the plan. I'm using the plan as an example, okay? Our hypothesis was that more sunlight results in taller plants. That was our hypothesis. So what would be the independent variable when we set up the experiment? Right, so the independent variable would be the amount of sunlight, right? You can control that, right? You can put the plants at a spot that have more sun, and then you can put it in a spot that has less sun. Right? If you are able to control it, then that's going to be your independent variable. Everybody okay so far? I asked that a lot, okay? Just like give you a chance to pause and think about it. Okay, so thank you for the feedback, guys. Appreciate that. Let's go back here to our valid hypotheses. Okay, so plant receive more sunlight, grows taller. The independent variable would be the amount of sunlight. What about the next one? Driving with the windows down will increase fuel consumption. If I were to test this in an experiment, what would be the independent variable? What is the thing that I'm able to control in this setting? Yeah, the position of the windows, right? Like, is it open? Is it closed, right? So we can write that down. The independent variable is going to be the position of the window. Okay, like the state of the window, if you would, right? Is it open? Is it closed? Is it up? Is it down? Okay. How about the next one? Taking melatonin will increase sleep duration. If I'm gonna go do an experiment, what would be the independent variable in this case?
The amount of melatonin.
Yeah, so it would be like melatonin consumption, right? Okay, so independent variable would be taking melatonin or not. Okay, like obviously I'm oversimplifying the situation here. If I actually want to see if melatonin will increase sleep duration, I'm not just gonna have two groups taking or not taking. I'm gonna have people who are not taking it, and then I'm gonna have people who are taking it at like different amounts, right? So like the first group might take, I don't know, like making this up, okay, like 100 grams. Next is it take like 150 grams and then 200 grams, right? And I'm gonna see the result. But the point I'm trying to make here is whenever you do an experiment, if you are able to control the thing, that thing you're controlling is called the independent variable. Which then takes us to the other thing that you are not controlling, which is the dependent variable. So for the dependent variable, this is the variable that is being observed or measured. So in an experiment, the goal is to determine whether or not changes in the independent variable have any effects on the dependent variable. Okay, you want to know if I change the sunlight, is that going to affect the height? You want to know if you change whether the window is open or not, will that have an effect on the fuel consumption? Okay, by changing the amount of melatonin a person taking it or not taking it, is that going to affect the sleep duration? Okay, so the dependent variable is not something you can control. It's not something you have control over. Right? You don't know how it's going to be affected, if at all, by the independent variable. And that's sort of the point of an experiment. Any questions?
Can you explain it? This one, dependent variable, once again.
Sure.
Mm.
So you understand, let's say the plant situation again, okay? In the plant situation, we're trying to see if the amount of sunlight is going to have an effect on the plant growth, right?
Mhm.
So you're changing the amount of sunlight. The amount of sunlight would be the independent variable. What are you going to be measuring in that experiment?
It's growing fast because of sunlight.
Well, you want to see if that's the case, right? So how are you
Yeah.
gonna, what are you gonna measure to see whether that's true or not?
When I observe that the amount of sunlight when the plant grows high, then it depends on the amount of sunlight.
Right, so what you're trying to say is we actually have to measure the height, right? We have to measure the height of the plant to see if there's a difference, right? So the fact that
Mm.
you're measuring the height of the plant is actually the dependent variable. Okay.
Oh,
It's the thing that you are measuring or you are looking at the end of the
yeah.
experiment. Is that better?
Yeah, the effect actually.
Okay.
The effect is
Yeah, the
dependent
effect
variable.
exactly.
Yeah.
Very good.
Okay. Yeah.
Yeah. Anyone else have another question? Okay, so a couple more things before we go to another thing. So let's say we set up the experiment, right? So this is the experiment. Okay, we have the control group. Control group. Okay, so like we're gonna have a plan here. That's our control group. Control group means no treatment. No treatment. We're not changing anything. This is just the standard condition. Okay, no treatment, no modification. Okay, and the purpose of the control, which you need to understand, the purpose of having a control is to provide a reference. Okay, to provide a baseline to compare with. Okay. If you only have one plant and then you saw that it grows 20 centimeter, right? Like, how do you know that's because of the sunlight? If you don't have a reference to compare to, how do you know 20 centimeter is like extra growth, right? Like maybe 20 centimeter is actually normal, right? Maybe 20 centimeter is actually less than normal. Without a control to compare to, you don't know. Sorry guys, I think my internet got cut off there. Oh, you guys are all here. Nice. Okay. In case this happens in the future, you just stay there. Okay. I'm gonna try to come back. Okay. Hold on. Oh, I might have lost the recording as well. I don't know. We'll see what happens. I'm sorry. Okay. What was I talking about? What was the last thing you heard me saying before I got stuck into the void? Do I have to talk about all these things again? What was the last thing you heard me say? The purpose? Okay. No, okay. So I was saying the purpose, thanks, Michael. The purpose of having a control is so that you have something to compare with. Okay, so you have something to compare with. Without a control, there's no reference. You don't know. Let's say you put a plant in the sunlight and then it grows by like 20 centimeter or something. Okay? How do you know 20 centimeter represent extra growth? Right? If you don't have something to compare to, how do you know 20 centimeter is extra growth? Maybe 20 centimeter is just normal growth. Maybe 20 centimeter is actually below normal growth. Like you won't know it. You won't know what it is unless you have something to compare to, right? That's why in an experiment you must have a control. Okay, so you don't change anything in the control, and then you would have the second group. Okay, the second group here is called the treated group. Treated group, or sometimes called the experimental group. Experimental group. This is the one that receives the modification. Okay, just one modification, right? You cannot change more than one thing. If you do change more than one thing, you don't know what is causing the result in the end. Okay, so like you would have a plan here. So in our experiment, the control group would be regular amount of sunlight. Okay, maybe that's 6 hours. Okay, I'm just making it up. For the treated group, it will be like extra sunlight, right? Like 12 hours. Is that okay? So then you wait, right? You do this for like 5-6 days, and then in the end, you're going to compare the results. Now, before we talk about the end, though, there is another important concept. Let me just write this in red here. Okay, standardize. Variables. Okay, so standardized variables are things that are kept the same between the groups. Right? Between the control group and the treated group, everything needs to be the same except for the independent variable. Right? So give me some things that have to be identical between the two groups. Yeah, you have to use the same plant. Same temperature, good. Okay, I'll say type of plants, okay? Type of plants, temperature, yeah, keep them coming, guys. Amount of water, type of soil. What else? Couple more, maybe. Source of light. Okay, like sometimes sunlight is a little bit unreliable, right? Like it might comes and go, cloudy, overcast, whatnot, right? So maybe you want to use one of those UV light, those indoor grove light. Yeah, exactly. Type of light, very good. Okay, and maybe the starting height of the plant. Okay, because growth is not necessarily linear, right? Plants that are already tall might not grow as much as plants that are like smaller, right? Number of days exposed to light, very good piece. Okay. Duration of experiment, right? Okay, so all these things are kept the same between the two groups. And so what's the purpose? The purpose of having the standardized variables is that if in the end you see a difference between the two groups, then you can say with confidence that the difference is caused by the independent variable. Right? If you see that one plant is taller than the other, then you know it was because of the sunlight and not anything else, because everything else you kept the same. Is that okay? All right. So let's switch to the study guide for a second. Okay. Question number 6 has a few questions with independent variable and dependent variable. Why don't I give you guys like a little bit of time, excuse me, to go through it. I'm actually going to try to put you guys in groups maybe, so you can try to do this together with your classmates. When I put you in groups though, the screen is gonna go away. So if you don't have the study guide printed out, maybe take a picture of it now. Okay, just take a screenshot of it, and then you will have it with you when you're broken into groups. Okay, so when I put you in the groups, you're gonna have to click join to go into the groups. Within the groups, I'll say the person whose name is the highest in the alphabetical order, you're gonna be the group leader. Okay, so you will start the conversation and try to get the answers, get the discussion going. Okay, we'll come back in about 5-6 minutes. Okay, so take a picture, and then I'm gonna set up the groups right now. Okay, go for it. Okay, I think we got everyone back in here now. Hopefully you had a good discussion with your classmates. Let's take up a few of them, okay? For the first one, does anybody want to share what the independent variable is? Actually, I think Kelvin typed an answer there, so we're gonna go ahead and use that. So in this case, the independent variable is going to be whether they watch the cartoon alone or with others. Okay, I'm just gonna save some time by highlighting it. Okay, you can of course write it out. And the dependent variable is going to be how funny they found the cartoon to be. Right? You can control whether the students watch it alone or with others, right? But then how funny it is, that's not something that you can control. It's something that you'll be assessing, something that you will be, it's the outcome, is the effect, right? Okay, how about the second one?
Is it whether the students study the textbook material in silence or with the television turned on?
Exactly, right? So this is study in silence or with the TV turned on. And what would be the dependent variable?
The grade on the comprehension test?
That's right. The grades on the test. Test result, exactly. Okay. Maybe let's just do one more here for the independent variable. What would it be? This one is a little bit tricky to articulate for some students. What do you think? Is it the kids' academics?
I might be wrong. No,
Sorry, what's that?
I might be wrong.
Oh, okay, yeah.
I'm
Well,
yeah, this was pretty.
no problem. Thanks for trying. Yeah, go ahead, Chi. Is it Chi? Am I pronouncing it right? See that you're on mute.
I'm pretty sure it's if the parents went to college or that they didn't go to high school.
Okay, so whether the parents went to college or high school. Anyone else? Do you agree? Do you have something to add to that? Okay, so actually, I think the independent variable is whether the teacher is aware of the student's parents' education. Right? It's not so much whether the parents went to high school or college necessarily, but whether or not the teacher knows about it. Okay? And then the dependent variable would be the child's academic potential rating. Right? So that one is a little bit tricky. Any questions about dependent and independent variable? I mean, there's another one, but I'll post the answer for the study guide later on. While we are waiting to see if there are any questions, I might as well show you where the thing will be. So you guys, what are you guys? 202, right? I think, yeah. If you go to content and study guide answer, like you see nothing right now because I hide them from you guys, right? Okay, but I'm gonna turn it on now. So you will have the answers, and I am also going to turn this one on. This is like a old video where I take up the study guide. So like if looking at the answer is not enough for you, you want to hear me explain it, then you would watch the tutorial as well. Okay, so that's the difference. You will find it under the study guide answer folder. Okay, let's go back to our PowerPoint slide here. So that's talking about the experiment. We wrote down the standardized variable already. And again, the purpose of having the standardized variable is so that when you see a difference in the dependent variable, you can say with confidence it was caused by the independent variable and not anything else. That's why it's so important to only change one thing at a time. So you can predict the result as well before you do the experiment. If the hypothesis is correct, then the plant exposed to more sunlight will be taller. If the hypothesis is incorrect, then the plant should be similar in height, or it's also possible when you give them more light, it becomes shorter. Right? Some plants actually don't like sunlight, right? So that's your prediction. And we're going to go ahead and do the experiment, collect the results after 7 days. You can see with 6 hours of sunlight, it only grew by 1 centimeter. With 12 hours of sunlight, it grew by 6 centimeters. Okay, so we can conclude that the experimental data supports the hypothesis. Our hypothesis was that more light leads to taller plants, right? And that's what the data shows. And that would be your conclusion. Now, this is, once again, I cannot stress the fact that this is an oversimplification. Okay? No one's gonna do an experiment with like a single subject compared to a single subject and then draw a conclusion. That would be very bad science. Imagine this, right? If they have the new vaccine and then they test it on one single person, right? Like, okay, you are the control, you don't receive the vaccine, you receive the vaccine, okay, you seems not to get sick after the vaccine, let's give it to billions of people, right? That's super terrible science, right? But this is an oversimplification. In real life, we need a much, much bigger sample size to draw any kind of significant conclusion. Yes, please, go ahead. I see that you have your hands up. Is that by mistake or you have a question, please? Okay, we'll come back to it. The question is in the chat box, I'm sorry. Can an experiment have more than one control? That is a great question. Yes, but I don't want to overcomplicate things. For now, we will just have one control. In some experiments, we need to have positive control as well as negative control in some cases to see what happens if the experiment does work and what happens when the experiment does not work. But we don't have to worry about that. If you're interested, you can stay behind. I can tell you more about it. But that's a great question. Okay, so bigger sample size in real life, and also in real life, once you draw the conclusion, it often leads to more questions, and then you're gonna have to do more experiments. So once you figure out that sunlight does have an effect on the height of the plant, then maybe the next thing to find out is what would be the optimal amount of light exposure to create the tallest plant, right? If 12 hours give you taller plants, maybe 18 hours is even better. Maybe 24 hours is even better. Okay, or maybe not. Maybe too much of a good thing is a bad thing. So you can do an experiment to find out. Okay. All right, let's do some poll questions and see if you learned anything from me. Go ahead. All right, I think I'm going to end the poll. Though I try to keep it under a minute so we can get things moving. The correct answer is hypothesis. Okay, hypothesis is a tentative answer. We literally wrote that down on the hypothesis slide. Okay, let's try another one here. Go ahead. Anyone else? Okay, the correct answer is experiment. Most of you got it right, which is very good. Experiment is the thing that you're going to be testing the hypothesis with, right? All right, let's shift gear and talk about something else. The scientific method, which now we understand involves all these steps, observations, hypothesis, and so on and so forth, right? Who came up with this idea, right? When was the concept of a scientific method first came to be? So a little bit of history for you, and along the way, maybe we'll understand a little bit more about what the process is. So there was this thing called spontaneous generation. Okay? Spontaneous generation was a theory that was proposed in the early mid 19th centuries. Okay, people noticed that if you leave a piece of meat outside for, I don't know, a couple of days maybe, then it will start to have flies buzzing around it and maybe maggots crawling on it. And so came the theory of spontaneous generation, which states that life arose from non-living matter. Okay? So the piece of meat was non-living, and if you leave it outside for long enough, then you start to see living things spawning from it. Okay? So that's what spontaneous generation is about. Okay, so some people supported this idea. Others, they say It's because there are microbes in the air, and they land on the food, and then it attracts the flies, and that's why there are flies. Right? Obviously, when you look at something like this now, you're like, hey, obviously it's not true, right? The flies probably came from the surrounding, right? Not like from the meat itself, right? But you got to understand, this is like early on, right? In the 19th century, and people didn't have the scientific knowledge that we do have right now. So they were still kind of, coming up with possible explanation of things that they don't understand just yet. Now, to further support the idea of spontaneous generation, there are these natural phenomenon that are happening, okay? And it's still happening to this day. Sometimes people will see fish or frogs or like other life form appear to be raining from the sky, right? And this is true. I did a quick Google search, and you can see there are a few headlines here. Texas witness a rare weather phenomenon as fish rain from the sky. Fish falls from the sky with rain in northern Mexico, and so on and so forth, right? So this people saw this thing happening. They're like, look, the fish, it's like that's where they came from. They came from the sky. Sky being non-living, spontaneous generation. Okay, now, before you get too mystified by this, does anybody know why this happens? Like, I mean, I haven't seen it with my own eyes, but like, I mean, I've heard about stories and read about it on the news. Do you guys know why fish would appear to be raining from the sky? Anyone? Has anybody heard of this before, or is this like new to you? No, no. Or you think I'm just making this up, right? All this is fake news, right? Okay, so what happens is like a water spout. Water spout is kind of like a mini tornado that goes through bodies of water, right? And it happens, and as the tornado goes through the lake or something like that, it scoops up the life form, okay, whatever is in it, frogs, fish, what have you, and then the force of a tornado send them inland, and then they rain from the sky. Okay, does that make sense? Yeah, like Sharknado. I never saw that movie, but yeah, I saw the trailer for it, right? It's kind of like that, exactly, right? But then with less lethal organism, right? So that's why it happens. Anyway, my point is, that's why people thought it's spontaneous generation, right? They didn't understand weather pattern back then as well as we do, and so they took this as proof for spontaneous generation. So in the 1600s, Francesco Redi, he was, I guess, like a scientist. He wanted to test the hypothesis of spontaneous generation using a series of what came to be known as the scientific method. Okay, so he basically made the observation, he asked questions, and he formulated a hypothesis, and so on and so forth. And he put the theory of spontaneous generation to test. So what was the observation? Observation is that flies and maggots can be seen around pieces of meat left out on the counter. And the question would be, where do flies come from? Is the rotting meat transformed into the flies? Okay. Hypothesis. That's what he, according to his notes, right, manuscript. I don't know who dug it up, but legend has it that he hypothesized only flies can make flies. Rotting meat cannot be transformed into flies. Okay, so that's a testable hypothesis, and he could potentially be wrong. So that's a great hypothesis. So let's take a note here to see what is happening. Okay, so continuing on the note. Yeah, like I'll post all these things, right? You don't have to worry about it if you actually missed anything. But do try to copy as much as you can. All right, so this is about Redi's experiment, Francesco Redi's experiment. Okay, remember, he's trying to test the theory of spontaneous generation. Now, I don't know for a fact that this is exactly what he did, but this this is like a version of what he did. Okay, according to the textbook and all the recordings of this thing, he had 3 jars. Okay, and in the jar he put a piece of meat in it. Piece of meat. So the first jar has no covers. It's just exposed to the air. The next one has a net covering. Okay, it's gonna put a mishmash on it. And then the last one, he sealed it. Okay, sealed. I don't know what he used. Probably not saran wrap, but he sealed it. Okay, and then he left these things outside, right, for I guess a couple of days, a week maybe, and then he came back and checked to see what's going on with the meat. So I have a few important questions for you. Which of these would be considered as the control? Now, don't tell me, right? We're gonna do the poll. Right? Which one is the control? Is it A, B, or C? Which one is the control? Okay, remember the control is the one that has no modifications, no treatment. You're not changing it. Okay, so it is going to be this one, control. Okay, this is the reference that you're going to be comparing with. Okay, everyone who chose C, have I convinced you why it is not C? Because you do something to it, right? You put something to cover it up. The control is the thing that you're not supposed to do anything to it. Does that make sense? So that's the control. These two would be the treated group, All right. What would be the independent variable? Independent variable. Which one is that? Okay, so we have exposure, the meat. Anyone else? What is the only thing is he changing the meat though? What do you mean by exposure? The 2 people said exposure. Can you elaborate so I know so that I understand what you're saying and I'm not misinterpreting you? The covering, yes, thank you. Okay, so the independent variable is the type of covering. Like, is it not covered? Is it covered? Is it partially covered? That's the only thing that he's changing, right? Okay, what about dependent variable? What is he trying to see in this experiment? Like after a few days, he comes back. What is he looking for? What is he measuring? What is he observing? Okay, change in the meat, specifically what aspect of the meat? Yeah, flies, right? It would be the presence of maggots and flies. Right? That's what he's going to be looking at. Remember, the theory of we have to go back to his hypothesis, right? I guess if you're confused, his hypothesis is that only flies can make flies. Rotting meats cannot be transformed into flies. So he's not looking for color change of the meat. He's not looking at the meat per se. He's actually looking for flies. Bottom line, will there be flies and maggots after 7 days, let's say? Okay. So that's the independent variable and the dependent variable. You probably can predict the result. Okay, we're just gonna go ahead and jump to the results. What do you think? No cover. Will there be flies and maggots? Yes or no? Flies, maggots? Yep, there will be flies and there will be maggots. If you don't trust me, try this on your own, okay? But don't send me any pictures. There will be flies and maggots for the control. What about the seal jar? You think there will be flies and maggots? Obviously not, right? Like we know that now, right? If it's sealed, nothing can get to the meat. The meat might spoil and be gross, but there will not be any flies or maggots. For the net covering, right? He also saw flies and maggots, but only on the net and not on the meat. Okay, so what conclusion can be drawn from this? Right? Only, well, I guess meat does not produce flies and maggots. Okay? Do you understand? It's a very basic thing. But then that actually started the whole concept of you know, the scientific method. I want to continue, but then I think you guys need a break. Just like 5 minutes, okay? Not too long. We'll talk about another guy when we come back. All right, see you in a bit. All right, let's keep going here. So even though Francesco Redi's experiment was convincing to some, many argue that, well, maybe spontaneous generation is not true for big organisms like a fly or maggot, but it is true on a microbial level. Like if you look at microorganisms, right? Maybe it's still true for spontaneous generation. So then there was another person. His name was Louis Pasteur. Yeah, I mean, you might not know him, but then you certainly benefit from one of his one of the techniques that he invented. Anybody know what technique I'm talking about? Like, look at his last name. Does that remind you of anything? Like, you know, when you drink milk or eat honey, what process makes them safe to consume?
Pasteurization.
Exactly. So this is the guy. Okay. So he did an experiment to show that spontaneous generation is not true even for microbes. Okay. So I'm just gonna briefly talk about that experiment with you. Okay. So this is Pasteur experiment. There we go. Right, so he had two flasks. And this is flask number 1, and he has another flask. This one looks like this. Okay, has a special neck. Okay, so this is an open top flask, and then this one, it has it's called a swan neck. Swan neck flask, because I guess the thing here looks like the neck of a swan. And he filled them up with some broth. Some broth here. There we go. Some, you know, beef broth, chicken broth, whatever, it doesn't matter. And what happens is he boiled them initially. Okay, both flasks were boiled initially to kill off any existing microbes. Okay. So that's part of standardization. And then he left them be, left them in the open for, I guess, a week, right? I'm not sure how long, a week, let's say. And then afterwards, he came back and he examined the broth to see whether there are microbes growing in them. And as you would expect, right, the open top flask has no microbe. Only the, sorry. Let me say that one more time. After a week, he came back and he examined the broth to see if there are microbes in it. Only the open top flask has microbes in it, and the swan neck has no microbes. Okay, so after 1 week, only the open top flask have microbes in the broth, right? Which is what you would expect, right? Because there are microbes in the air that might land into the flask, right? There are microbes here in the air as well, but when they land, they are all trapped here. Okay? They cannot crawl all the way up, right? So the flask, the swan neck flask, the broth remains sterile. Sterile means it's like no bacteria at all. Okay, so based on this result, he was able to definitively reject the theory of spontaneous generation. Any questions for me? For Pasteur experiment or for Raydi's experiment or anything in general? Great. Okay, let's do a poll. Okay, so the correct answer would be the type of flask used, right? You're only changing one thing, and the thing that you're changing is the independent variable. So both flasks are the same. The broth are actually the same, and he boiled both. It's just a type of flask. Is it open top or is it swan neck? Right? So that's the independent variable. The answer is B. Okay. We don't have enough time to do this, but this is the thing that I found on the internet. Right? There's all sorts of wrong things and misleading things on the internet. But this one, a lot of people believe it. And I want to see if you think it's true or not. The person claims that there are two plants, and if you water the plant with purified water, and then the other plant you water it with microwave water, after 9 days of doing this, the one that was watered with microwaved water will die, and the one that uses purified water continues to live. Right? And they're supposed to say that's why you shouldn't microwave your food. If it kills the plant, it can't be too good for your health, right? What do you guys think? Do you think this is true or not? If you think it's true, please choose A. If you think it's false, please choose B. What do you think? A for true, B for false. The poll is anonymous, okay? So you can tell me your true feeling. What do you guys think? Okay, maybe a couple more All right. I love this. This is amazing. Look at the result. It's half, half. Half of you think is true. Half of you think is not true. This is amazing. Okay. You can actually try this out and find out for yourself. Okay. Now, I just want to clarify. I think maybe some of you misunderstood a little bit. When they say microwave water, they don't mean like microwave the water for 2 minutes and then immediately pour it on the plant, right? Like that's obviously going to kill your plant, right? Because it's like boiling hot, right? Like, you know, you gotta cool the water down back to room temperature and then you go water them. Okay, that's what they mean by microwave water. Okay. Anyway, you can do your own research online and then tell me next week what you find out. Okay, but it's very interesting. Half here. We must carry on with the with the lecture and leave the fun stuff behind. Okay, next we will talk about experiments involving human testing. Now, involving human makes things a lot more complicated, right? Because we have to, for one thing, we have to follow carefully designed ethical guidelines. Okay, when we do experiments with humans, we need to have consent from people who are participating. Okay, this wasn't always the case. I'm sure you might have read some horrible story about human testing subject in the past. Okay, hopefully all that is in the past now. Like nowadays, we're supposed to have very stringent ethical guidelines and policies surrounding consent. Right, the person has to be willing to participate in the experiment. You cannot coerce them into it. You cannot force them into it. It has to be a voluntary, ongoing consent. Okay, just because they consent to it at the beginning, if midway they're like, this I don't feel good about this anymore, I want to withdraw, you have to let them. Okay, so that's the consent. Has to be voluntary. Has to be protection. There has to be protection from physical and mental harm, reasonable protection from these things. Okay, so like you cannot, let's lock these people in a room for a month and see what happens to their mental health. Like that's not ethical, right? So there are many things you have to follow when dealing with human testing. And more importantly, because humans have these psychological bias sometimes, and in an experiment, especially if you're testing something that can be skewed by a bias or psychological effects, you want to minimize that by including a placebo. Okay, let me just give you a quick example to help you understand that. When my kids were younger, they fall at the playground or something, and then it's not even bleeding. Okay, it's just like a minor bump and maybe a little bit of skin peel off. And then my younger one is really dramatic. It's like the whole world collapses. She'd be like crying in the playground. It's like, oh, I can't walk, right? And then I go over and I give her a Band-Aid, okay? And that fixed everything. Now, does the Band-Aid do anything? Probably not, right? Okay, because it wasn't bleeding or anything. But it's like a psychological comfort for her. Right. And so as soon as the Elsa Band-Aid goes on, all is well, and then she could go back to playing. That's the kind of psychological effect we're trying to minimize when we are dealing with human subjects. Okay, adults have bias as well, right? When I was talking about the melatonin, whether it actually helps you sleep better or not, right? Like, what if it's not actually the pill that's helping? Maybe it's just the fact that these people think that the pill is going to help, and therefore they feel more relaxed, they feel more at ease, and therefore they sleep better, right? So to minimize these kind of psychological effects, to minimize the bias in humans, more often than not, you have to include a placebo. Okay, so a placebo is a sham treatment. It's not actually the drug that you're trying to test. It's not actually doing anything. We tell them you are receiving the actual thing, but in fact, you are not. That's what a placebo is. So experimental setup, I guess I already went through this. I'm not going to go into great details for it again. So if you think about testing a vaccine, right, like a new vaccine, then you would have two groups of people. Okay, like, I don't know, 1,000 people here, okay? And then you would have another group, okay, another 1,000 people. So these would be receiving the vaccine, the experimental vaccine, and these people would be receiving the placebo. Okay, so the placebo acts as a control in this case. Right, so what's the difference between the vaccine and the placebo? Well, in this case, it's not so much about psychological effect that you're trying to minimize, okay? It's more about providing like a baseline to compare with. It's the same purpose as the control. Let me try to explain that a little bit further. Yeah, so in a vaccine, you have standard ingredients. Okay, most vaccines have the same standard ingredients, including maybe a little bit preservative. There is a little bit of solvent to dissolve the stuff in. So you want to have all those things except for the active ingredient in the placebo. Okay, and then the vaccine will be the actual vaccine, right? So it's a little bit different from the control in the sense that traditionally the control is the group that's not receiving anything at all, but here you are giving them something, okay? But you are just giving them a blank, right? It's everything in the real vaccine except for the active ingredient, right? And then so you can compare the results between the two groups. Does that make sense? Okay. Now, this is not related to experiment, right? This next example, I just want to show you, like, in the real world, when would a placebo be used, right? So this has nothing to do with experiment. Don't get confused. So birth control. There are different forms of birth control, right? Different forms of contraceptions. One type is to take contraception pills, right? So there is this contraception pill by the brand name of Freya 28, and if you buy one, it comes in a little package like that. It comes with 3 weeks of the actual pills, and then it comes with 1 week of green pills, which are the placebos. This is the placebo. Why would you pay full price for only 3 weeks? Why do they include a week of placebo? Anybody want to tell me? No, they're just cheaping out on you, trying to cut down on the the production cost, so they give you a week of placebo. What's the reason? Okay, I'll tell you then. So the 3 weeks of white pills is going to basically prevent ovulation, right? No ovulation, no egg, no pregnancy, right? But while you're on these pills, actually it prevents the period from happening. And so women often would want to have the period, but instead of having it in a unpredictable way, I mean, like, it's predictable, but then with the pills, you can actually control it more precisely. And that's what the green pill is. Okay, by taking the green pills, it allows you to have the period. And in addition, it helps you keep track of time. So by the time you finish the green pills, you're like, okay, let's start the next pack. We should be on the white pills again. If they don't include the placebo and it relies on the person to kind of keep track of the time on their own, sometimes they forget, right? Sometimes they forget what days it is, and then it might mix up the schedule. And then if the goal is to prevent pregnancy, then missing a few days of contraception can actually change the result drastically, right? So that's what the placebo is for. They are just for keeping track of time when a person decided to get off the pill. All right. So what happened with the company was that Someone made a mistake, I guess, in the production line, and there was a whole lot of them, where they swapped the placebo with the actual pills. Right, so instead of getting 3 weeks of the contraception and 1 week of the placebo, the package came with 3 weeks of placebo and only 1 week of contraception. And as you can imagine, if people didn't know about this and they take the pills, thinking that they are on the contraception when they're actually not, they're just taking placebos, right? That could lead to undesirable outcome. And so once this was discovered, the company issued like a recall, and they're saying, people who are taking this lot of pills, make sure you go on backup contraception. All right. So that's what a placebo is for in a non-experiment context. Moving on. When we do experiment, there are 2 ways to do it. One way is called blind experiment. In a blind experiment, the subjects, as in the people who are participating in the experiment, the people who are being tested on, they don't know what kind of treatment they are receiving, okay? But the person who's conducting the experiment, they know. So that's a blind experiment. So this will minimize the bias in the subject, okay? Because they don't know what they're receiving. And then there is what's called double-blind experiment. In a double-blind experiment, the person receiving it does not know what they are receiving, and the person who's administering it also does not know what they're giving, okay? Now, why would you ever do a double-blind experiment? Isn't a blind experiment enough? What's the extra advantage of doing a double-blind experiment? Anyone? No bias from who though? Right? The blind experiment already eliminate bias from the subjects. What's the additional purpose of not telling the scientists? Right. So in some cases, the scientists might have a conflict of interest. If I work for a pharmaceutical company and I manufacture this drug, I have a financial interest in having the product working, right? So when I evaluate the effectiveness of the drug, I might have bias in how I assess it. I mean, it shouldn't happen, right? But humans are humans. We can't eliminate the bias, and that's why for high-stake pharmaceutical product, it's the gold standard to do a double-blind experiment. The vaccines that we received during the pandemic, those vaccines are tested in a double-blind experiment. Okay, Pfizer, the people working for Pfizer doing the research, they don't know what they're giving the people. They don't know if it's the actual vaccine or if it's the placebo that they're giving. So when they assess the results, right, there is not going to be bias. Some third party who's not invested in the situation, they would have the information, they would have the data, they would analyze it, and then that way the results will be without bias. Okay, so double blind is the gold standard. All right, let's take a look at this result here. Let's say there's a new drug for jet lag. Okay, jet lag is what you get when you go to a different time zone. Okay, like you're 4 hours behind or something, so you feel a little bit sleepy or you can't sleep when you come back from the vacation. So there's a new drug called sleep, and we want to know whether or not it is going to reduce the symptoms of jet lag. So this is the result. Okay, this is the result. We have 2 groups, and we can see in the control group, 80% of people reported there are jet lag symptoms. People who took the drug, they only 30% of them experience the jet lag symptoms. So based on this, do you think the sleeping pill works? What do you think? Let's do a quick poll here. If you think it works, say A. If you think it doesn't work, choose B. Does it work? Or does it not work? Okay, most of you think this works, and that would be correct. Because in the control group, remember, we are giving them the placebo. The placebo is not supposed to do anything. You give them a pill, and they're like, okay, here we go. They took it, and then as expected, if you take something that is nothing, it's not going to have any effect on the situation, right? And so, lots of people still report jet lag. Whereas if they took the pill, it reduced the jet lag. So this is what the result would look like when it's effective. In this case, it's ineffective because look, whether you take the pill or you take the fake pill, both situations reduce the jet lag symptoms. So if you see something like that as a result, then it's telling you it's not the drug that's helping you with the jet lag. It's the fact that you tell these people you're taking something that will help you, and then their psychological effects helps them sleep better, right? Reduce the symptoms of jet lag, right? So in this case, both control and treatment group experience a reduction in symptoms. That tells you that jet lag is a psychological thing. It's not something you can treat with medication. Okay. Any questions before we move on between this and this? Okay, almost there. Please try this out. This is another application type of question. Okay, anyone else before I close the poll? Now this one is a little bit lengthy, right? Okay. So 1 milliliter of experimental drug diluted in saline solution, saline just means salt solution, is injected into 20 pregnant mice to determine possible side effect. Which of the following would be a suitable control? Well, if you are testing it on pregnant mice, then you shouldn't be using male as a control. Okay, remember, you try to keep everything the same, right? Except for the drug. So if it's pregnant mice, you shouldn't be testing it on non-pregnant mice either. So for the control, should I give them 2 milliliters of the drug or 1 milliliter of the saline? Okay. The answer would be just the saline. The purpose of the control is to compare it with the baseline, with the reference. Right? You cannot compare drugs with more drugs. You should compare drugs with no drugs. That's why the answer is E. So just a couple other small things and it will be done. When we interpret scientific data, when we interpret data from an experiment, we have to pay attention to not over-interpret the results. Okay, sometimes there are correlations between two variables, but correlation does not necessarily imply causality. Just because two things are correlated with each other, correlated means like if one goes up, the other goes up, or if one goes up, the other goes down. If just because there is a trend between two things does not necessarily mean one thing causes the other. Okay, so over here we have a correlation between getting a cold and how stressed a person is. According to this graph, you know, if a person is really, really stressed, then they have a high chance of catching a cold. That's a correlation. But it does not necessarily mean stress causes cold. In fact, it could be other underlying situations, right? A person might be stressed because of illness, poor diet, little exercise, or little sleep. All these things might also contribute to a weaker immune system, therefore a higher chance of catching a cold. Okay? So just because you see correlation between two things, you sometimes have to dig deeper to see if it's actually causing it or if there are some underlying factors that's contributing to what you're observing. There is an interesting website you can visit. You know, if you look for something, I wouldn't call it fun, okay, but something interesting to do, okay, to look up, you can go there, and it shows you all kinds of weird correlations that they found. Okay, for example, the black line here represents the number of individuals who died as a result of being tangled by their bed sheets. Okay, apparently that happens. And then the red line shows the amount of cheese that's being consumed per capita. So you can see the two is closely correlated. But I can almost say with certainty that eating more cheese is not going to increase your risk of being tangled by the bed sheet. Okay, so this website actually illustrates an interesting fact that just by chance, okay, randomly, two things that have nothing to do with each other, by chance might have a strong correlation with one another. Okay, and so when we look at headlines, especially nowadays, there's a lot of misinformation, a lot of clickbaits, right? When you see a flashy title, you really need to dig deeper to see whether it's true or not. Okay, so I did a quick search on you know, whether drinking coffee is good or not, because you know a lot of people drink coffee, and I find you know some articles. I did this a while ago. Okay, this was done in 2016. I've been teaching for 20 years. Some of my slides are actually you know a little bit older. Anyways, so between 2016, I'm sure you'll find similar headlines you know nowadays. So it says drinking more coffee might reverse liver damage from booze. Okay, so you know people who love drinking coffee would look at this and see it as an affirmation, right? Like, yeah, I knew drinking coffee was good, so that you know it justified their consumption. Okay, next one, consuming coffee may help prevent colon cancer. Another thumbs up. Okay, and then here, coffee consumption in either parents may raise miscarriage risk. Okay, so people who don't drink coffee, they're like, I told you not to drink so much. See, it's not good for you, right? So, you know, my point is there are a lot of these headlines out there. And many, many times, these are nothing more than random correlations. If you have a big enough database, some numbers are just gonna correlate with others just by chance. And we cannot read too much into it. And also we need to understand like who's doing these research, right? Who's paying for these research? They love saying a study shows that blah, 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 blah. But then like everybody reads the headline, but very few people, I would say, right? Less than 1% of people who read the headline would actually go find the study and look at how the experiment is done. Okay, for example, this one here, drinking more coffee may reverse liver damage from booze. It may be that's funded by, I don't know, I'm just making this up, okay? Maybe it's funded by like the LCBO, right? Maybe they want people to believe that so that, you know, they could maintain their sales, right? So there might be some conflict of interest in a situation like that, okay? That was just like a hypothetical situation. So, anyway, next time you see a catchy title like that, before you forward it to all your families and friends, maybe take a closer look using the information that we've learned from this week. Also, you have to look at the sources, right? So primary sources, these are original documents or original research that are often written by the person who's doing the actual experiment. Right? So we have academic research, and these are often printed in peer-reviewed journals. Peer review means other experts in the field has to approve your work first before you can publish it. Okay, let's say I am doing research in cancer, okay, colon cancer. When I publish my results, other experts in the colon cancer research field will scrutinize your work, make sure it was done properly with the proper control and the proper methodology before you can publish it. Okay, most of the time, this makes it more credible. Does that mean all academic research are reliable? No, there are cases where people fake their data and you know it made a mess. But those are rare instances. Okay. Other examples of other examples of primary source include interviews, reporting from a live scene, diary, you know, even fictional work. If it's the original person doing it for the first time, then it's considered as a primary source. Secondary sources usually summarizes or interpret the primary results. So encyclopedia, textbooks, magazine, biographies. I'm not saying that these are not reliable. They could be, but it's also possible that they might contain bias or views of the person who wrote it. Okay, sometimes you know, people take excerpts from a piece, only the part that they want to emphasize, and then they write an article about it, and then you are missing the whole context, right? And when things are taken out of context, then it could be a dangerous thing. Okay, so when you do research, well, you don't have to do any research for my course, but I'm sure you might write papers sometime in your college career. So when you do evaluate your sources, you have to make sure that they are appropriate. Okay, and that's it for lecture 1. Now, before you go, I want to do one more thing with you since we have 5 minutes, and I do not like to waste time. So let's go back to the study guide for a second. Again, I already posted the answer for all these things. I want to talk about this situation right here. Okay, a farmer wants to determine if feeding cows with high protein diet would increase milk yield. Okay, if you feed the cows with more proteins, are they gonna make more milk? The hypothesis would be, you know, you either think yes it will or it won't. Right? That's the easy part. If you think it will, then you would say feeding cows with high protein diet would increase the milk yield. If you think it does not, then you say it does not. Describe how the experiment should be set up. Is a placebo needed for this experiment? What do you think? Do we need a placebo for this? Should we include a placebo just to minimize bias? Yes or no? Okay, Cheyenne said no. Eduardo Uthman said no. Why not? Okay, please say yes, we need a placebo. Okay, let's do a quick poll. Placebo or not? Yes, A for yes placebo, B for no placebo. Okay, anyone else? Interesting. we have half again. Okay, half people say no placebo, the other half say placebo. I want to hear from the people who say you don't need a placebo. Why not? Just unmute and tell me. It's probably faster that way. Why do we not need a placebo?
I mean, they kind of get like an opinionated response after the experiment.
They are not. They are going to get like opinionated results for the experiment.
They cannot give one. Like, I mean, animals. I
They're
don't think
animals, right?
they-
Exactly, right? They
yeah,
are cows. Okay,
yeah,
cows do not have bias, right? Okay, the
Yeah.
cows won't even know you are doing an experiment on them. It's not like they're like, oh, okay, I'm gonna hold out my milk on you, right? Like, because I know you are messing with my milk yield, right? Like, it's we don't need
maybe,
that, right?
maybe.
Exactly. Yeah, they would be weird if they do. Okay, so placebo is not needed because animals don't have bias. Okay, but that doesn't mean we don't need a control. So we will have two groups. We have a control group and we have a tested group, a treated group. Treated group. Okay. What do we give the control group here? If we are testing whether protein diet will increase milk yield, for the control group, it will be regular diet. Okay. I'm not saying you're gonna remove all the proteins. Okay. Yeah, no, I understand, right? Like, yeah, placebo and control seems to be like a interchangeable word, right? Okay. Sometimes it is, but you know, in this context, to give a placebo would be to give them like a sham treatment. Okay. Yeah. Sorry for the confusion. Okay, so regular diet. And what about for the treated group? What do we give them?
The meat, the protein.
Yeah, high protein diet, right? I'm not sure if they eat meats per se, because you know cows are
Oh, sorry,
grass fed.
not meat.
Yeah, but no, I get what you mean, man. Like some kind of high plant protein diet. Okay, we understand this, guys. I'm just gonna ask you to do one more thing before you go. I know time is cutting close, but I want you to scan the QR code here if you can, and I want you to tell me 3 standardized variable for the cows. Okay, could you do that for me, please, before you go? Here, let me present this thing. It's gonna work. Okay, so there is the QR code if you want to scan it. If not, you can visit menti.com. It is in the chat box, and you can key in the code at the top. Okay. I want 3 standardized variables for this experiment, this cow experiment. Yeah, if you can't scan with your phone, that's okay. No worries. Okay, you can go to the website if you want, or you can just write it down. Okay, I'm looking for 3 standardized variables for this experiment. Okay. Oh, the result shows up high response. Oh, there we go. Okay, I hide it. Now nobody can see. Okay, so I have one person who did it. Thank you. Okay. If you are able to, please do this. I know sometimes people are, watching the lecture from work. I get it. It's fine. Sometimes people are driving as well. Don't do anything dangerous. If you are able to, if in a safe environment, you can participate. Okay, what do you need to keep the same between the 2 groups of cows in order for this experiment to be valid? Okay, well, we only have 6 people, but you know, I don't want to keep you guys too long, so let's take a look at what we have, and we're gonna go from there. All right, housing of the cow, that's good. I assume that means like where you keep the cows, right? You want to keep them in the same area. Type of feed, amount of food, age of the cow. Very good. Now, not the amount of milk produced. The amount of milk produced, that's the dependent variable, right? That's what you're trying to measure, right? So that shouldn't be something that you keep the same. In fact, you can't control it, right? How much milk the cow makes it's up to the cow, right? So to speak, right? Type of, I don't know what that means. Farm or wild. Yeah, I mean, like it would be farm cows, right? Assume because you're not gonna feed the wild cows, right? Quality of the feed, other than the protein, everything should be the same. Okay, that's actually pretty good. I am glad nobody puts gender, because usually that's the case. Some people put gender, and if this was a test question, it would be wrong because only female cows can make milk, right? So there's no need to standardize this. I mean, it's already standardized, right? By default. Yeah, that's pretty much it for now. Okay. Thank you so much for coming and staying. I hope to see all of you again next week. Please work on the study guide. Look at the answers if you need to. Check the tutorial video. And feel free to email me if you need help with anything. So next week, we will start on lecture 2. Make sure you print those things, okay? Have a good one, guys. Bye-bye.